Hello, welcome to MadTech. I thought I'd take a little bit of time to introduce you to one of my new projects. This is actually a project for work. My day job is a mobility assessor, and basically I take people out for test drives on mobility equipment. And because of this COVID-19 thing that's been going around recently, when I go back, which I was hoping it all was done by today because I'm going back tomorrow, I'm looking for a way of stopping the wheelchairs and the scooters remotely, because normally what I would do is just pull the key out or something if there's going to be an accident. So this project is to make a remote cutout for mobility equipment. So at the moment it's early stages. I've written some software and I just thought I'd show you where I am at this stage. Okay, so this is my sort of knock-up just to allow me to do the programming for my remote transmitter. This will be, well, this is the stop button as it is. Obviously it's running on a little nano, and we've got a little transmitter module there. But eventually it'll obviously be cased up, it'll have a battery on it. I've got some different buttons here. So on off button I'll put on it, and the case will be 3D printed. The stop button will be obviously a bit better as well, so something like that. Obviously this is all to come in the future. And then we've got the receiver module, again running on another little nano, and again this is not a complete thing, it's just the bits I needed to put on to write the software basically. So at the moment, if the scooter is disabled, the red light LED will come on. What it's actually going to be controlling now is a small relay. These things work by basically shorting the charging pin. It's actually got an inhibit pin which actually gets connected to the negative on most mobility scooters, and this relay will basically do that. So this unit will plug into the charging port on the scooter or wheelchair and then link up the inhibit pin with the minus on the charging port, which will cut it out. So obviously we'll need the relay, diode to protect it, a little transistor and some other bits to make that work. There'll also need to be a bridge rectifier of some sort so we can run it from different polarities without having to rewire it each time. The blue light, that's actually just at the moment is just a blue light, but it's supposed to be a buzzer, but I didn't want the buzzer going off while I was trying to program this and test it. So that basically buzzes when you're out of signal to give you a warning that you're too far away from the assessor and you need to go back. So I'll give you a little demo of this working now, I think. Okay, so here we have the receiver module powered up. I'm actually running it off a small LiPo unit here. Obviously this would be the scooter battery in the future, and it would actually be coming in and being powered through this small circuit here, with a bridge rectifier as well. But obviously I don't need that for programming, so I've omitted it for now. So as you can see at the moment, it is the blue LEDs going off and on, which is basically saying the beeper's beeping, we're at a range, it's not picking up a signal, and the scooter has been inhibited, which is signified by the red LED. Now, obviously that's because my transmitter is not powered up at this stage, so I will power her up right now. Just pop that on. There we go, so that's now powered up, and we come back over here. Now the blue light has stopped flashing, saying it's picked up a signal. It takes a few seconds and then the scooter is re-enabled, and obviously if I need to stop the scooter, we can push the button, transmits the stop signal and stops the scooter. It gives you a few seconds and then it will come back on. If it goes at a range, which I'll do by just simply cutting the power to the transmitter, it'll beep to give you a few warnings. That's the blue light going off, and there we go, it's now cut it off. There is a full menu system to allow you to change the timings and things. I'll show that on another video. But that's in a nutshell, that's it for now. Thank you very much for watching. Cheers, bye.